All right, today we're going to talk about 5-2 mid-segments of triangles. So the triangle, or by the end of this lesson, you'll be able to use these properties of mid-segments to solve problems. So the triangle mid-segment theorem, it states, if a segment joins the midpoints, so remember the midpoints we talked about yesterday, it is the very middle of our line. So if it joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half as long. So if we look at our diagram over here, if I know that D is the midpoint, so D is the midpoint of segment AC, and I know that E is the midpoint of segment CB. So since I know that they are the midpoints, look over here, look at AC. Segment AC, D, I know it is the very middle because look, there's one tick mark here and there's one tick mark here. So that means that this side, my green side, is the same length as my yellow side. So since they're the same length, then I know that D is at the very middle of that segment. Same thing with E. I know that E is the middle because CE and EB both have two tick marks. So they are the exact same length. So since I know these things, then I know that segment DE is parallel. So remember those two lines mean that they are parallel to segment AB. And I would know, here's my formula, that DE equals 1/2 of AB. So to go back over that, DE is parallel to AB. So my two red lines here, DE and AB, are parallel. So they go on and on forever and they never touch. Then I know that DE, so here's my, now I'm going to color it pink, DE is half as long as AB. So let's look at an example here. It says in triangle XYZ. So we don't have a triangle here. They didn't give us one, so I'm going to draw one. So triangle X, Y, Z. A is the midpoint of XY. So segment XY is on this left side here. A is the midpoint. So I'm just going to draw a point that looks somewhere in the middle. A is the midpoint of that segment. B is the midpoint of YZ. So I'm going to draw a halfway point over here that looks very similar to a midpoint. And C is the midpoint of ZY. Oh, here we go. ZY is down here. I'm going to put a dot where I think the middle is and label it C. If you notice here, they just gave us three segments. They create a triangle. So I'm going to connect the dots. So now it says, what are three pairs of parallel segments? So if you notice on this example up here, this diagram, our parallel segments, they go on and on forever and never touch. So the triangle that looks very similar to the diagram up there is this one. And then it has a line that goes straight like this. And it told us in this diagram up here that DE was parallel to AB. So down here, the one that looks very similar would be segment AB that is parallel to segment XZ. If you notice, these two segments here, they go on and on and on forever, and they would never touch. So now if we kind of tilt our paper, our computer, let's look at this triangle over here. So I'm going to draw it in blue now. So it's the same triangle, but now let's look at this side. So what two lines are parallel now? So remember, they can't touch, they have to go on and on forever. This one would be segment AC. So if you notice, it's that middle segment in our triangle. And whatever other segment that it doesn't touch, or that third side, it is parallel to. So this one's parallel to YZ. So if you notice, AC is in the middle of our triangle. It is parallel to YZ. And then our last one, I'm going to do it in green. So same triangle, but now it's this side. So now my green side, which is BC. So BC touches this side and this side. So it can't be parallel to that one because it touches that. So it would have to be this side over here, which would be XY. So your middle segments in your triangles are always parallel to one of the edges of your triangles. It's parallel to the edge that it does not touch. All right, to the right over here, it says, what are three pairs of parallel segments in triangle DEF? So three pairs of parallel segments. I want you to just pick one of them, submit your answer, and then we'll go on to the next problem. All right, this next one says, in triangle QRS, TU and B are midpoints. Find TU, UB, and QR. So remember, up at the top up here, it told us that my DE, so my segment that's in the middle, is half as long as the piece of the triangle. So it's wanting us to find TU. So TU is in green. It's wanting us to find UB. UB is in pink. And it's wanting us to find QR. QR is in blue. So that's what we're looking for. Let's do TU first. So TU. First things first, we need to figure out what TU is parallel to. So TU, what line is TU parallel to? So it has to be parallel to something out of our big triangle. So not our mid-segment. The mid-segment's the middle of our triangle. So it has to be something out of the whole triangle. It cannot touch our triangle because it has to be parallel. So the one that it is parallel to would be this one right here. So those two lines are parallel. So since they are parallel, if you look up here at the top, the mid-segment is parallel to the outer segment of our triangle, or that third side, and it is half as long. So TU is half as long as SB. I think that's a B. Oh, that's an R, sorry. SR. So TU is half as long as SR. Well, we know that SR is 40. So TU equals 1/2 of 40. What is half of 40? So 40 divided by 2. TU is equal to 20. What about UB? So UB is in pink. Now let's find what side UB is parallel to. So there's our whole triangle that I drew in pink. So UB is half as long as, it is parallel to QS. UB is half as long as QS. Well, QS is 50. So UB is half as long as 50, or 50 divided by 2 is 25. And then the last one, QR. So QR, what mid-segment is QR parallel to? So now we're on the outside of our triangle. We have a side of our triangle, not the mid-segment. So the midsegment that is parallel to QR would be this piece right here, which would be TB. So QR, so now we kind of have to look a little different here because QR is our outside of our triangle. So TB equals 1/2 of QR, but we know that TB is 30, so I'm going to erase that and put a 30 here. So 30 equals 1/2 of QR. So now since the 30 is on the other side, instead of dividing, we're going to multiply. So 30 times 2 gives us 60. So QR equals 60 degrees, or 60 units, I'm sorry. So the next one, it says in the figure to the right, AD is 6. So I'm going to go label that. So AD right here is 6 and DE is 7.5. Find the measures of DC, AC, EF, and AB. So you're going to have to use your tick marks here. So if this side has 2 tick marks and this side has 2 tick marks, this side is 6. What is this side? It would also be 6. Good job. So DC would be 6. AC, so now if I know that this side is 6 and this side is 6 and I want the whole thing, what will that one be? 12. Good job. We just have to add them together. So now it's asking for EF and AB. So EF, we just learned this. EF is parallel to what side? It's parallel to AC. So remember that is half as long now. So EF equals 1/2 of AC. So you're going to figure that one out. And then AB. AB is this side over here. What side is, or what mid-segment is parallel to AB? It would be this side right here. It would be DE. So AB equals 1, oh, sorry, I wrote that one wrong. So DE equals 1/2 of AB. So figure out those two, submit your answer, and then we'll go on to the next one. All right, this next one says, a geologist wants to determine the distance AB across a sinkhole. Choose a point E outside the sinkhole. She finds the distance AE and BE. She locates the midpoint CD of AE and BE and then measures CD. What is the distance across the sinkhole? So if you look at this picture here, we are trying to find this piece right here that I have in blue. That's what we're trying to find. So remember, our mid-segment is half as long as our piece of our triangle. So the mid-segment here, remember that mid-segment is the middle part of our triangle, which would be this piece right here. So 46. 46 is half as long as our triangle. So the mid-segment, let's go back up here and look up here. So the mid-segment is half as long as AB. So our mid-segment was 46 equals half as long as the side of our triangle, which was AB. So to figure out what AB is, or that piece that I have in blue, we need to get this AB by itself. So remember, I need to get this 1/2 over here. To get 1/2 to the other side, I need to multiply. So I'm just multiplying 46 times 2. 46 times 2, we get 92 feet. So if you're given the midpoint or the mid-segment, you're multiplying by 2. If you're given the outer edge of your triangle, you're dividing by 2. So given the midpoint, mid-segment, you multiply by 2. If you're given the outer edge of the triangle, you divide by 2. So on your side, you are trying to find the length of the bridge here. So this side is 2,640, this side's 96.3, and this side's 96.3. So you're finding the bridge. So submit your answer. We'll go on to the next one. In this last one, it says BE equals 2x plus 6 and DF equals 5x plus 9. Find DF. So let's go label what they just gave us. BE, so that's this piece right here. That is 2x plus 6. DF, which is this piece right here, is 5x plus 9. Find DF. So they want us to find the whole length of DF here. So remember, I just said earlier, if you're given the mid-segment, you're going to multiply by 2. If you're given a piece of your triangle or you're given a side of your triangle, you divide by 2. So if you notice here, we're given both. So let's look at them. The mid-segment, we have 2x plus 6. We can multiply that by 2, it'll be pretty easy. The outer edge of our triangle, we're given 5x plus 9. If we divide that by 2, we're going to be dealing with decimals and everything else, and that's just going to give us room for error. We don't want to do that. So the easiest thing to do here would be to multiply this 2x plus 6, because initially we're trying to get them equal so we can add them together and figure out what they are. So 2x plus 6 times 2. So 2x plus 6 times 2, we have to distribute. So 2 times 2x, we get 4x. 2 times 6, we get 12. So now I have 4x plus 12. So my 4x plus 12 is equal to my 5x plus 9. Since this was half as long, I wanted to get them equal so I can solve for it. So now I can solve. So now I can go in, circle my x's, box in my numbers. I need to get my circles together. Since they're on separate sides of the equal sign, I have to move them, can just combine them. So minus 4x minus 4x. 4x minus 4x goes away. I'm left with 12 equals 5x minus 4x, we get x plus 9. Same thing here, I need to box in my numbers. So x, I need to move this, I need to get this x by itself, so I need to move this 9. So minus 9, because it's a positive. So 12 minus 9, we get 3. So my x is equal to 3. So now if I go back up here and look, it says find DF. So is DF 3? No, DF was 5x plus 9. So now I know that x is 3, so I'm going to go plug it in. So 5 times 3 plus 9. 5 times 3 is 15. So 15 plus 9, we get 24. So my DF is equal to 24 degrees, or 24 units, sorry. On your side, it says if EC is 3x minus 1, so EC here is 3x minus 1, and AD, that's this whole side here, is 5x plus 7. Find EC. So now you're trying to find this piece right here. You're trying to find your mid-segment. So we know that EC is 3x minus 1, but we want the actual number. So once again, it's always easier to multiply by 2 than divide by 2. So remember, your mid-segments, you multiply times 2. Your edge of your triangle, or the side of your triangle, you divide by 2. So our mid-segment here, or the piece that's in the middle of our triangle, is this 3x plus 1. So we have 2 times 3x plus 1. Oh, 3x minus 1, sorry. So 2 times 3, we get 6x. 2 times negative 1, we get negative 2. So now I basically just made my EC 2 times longer. Since I made it 2 times longer, I made it the exact same length as AD. So now these two lines here are exactly the same. So now since they are exactly the same, or they are congruent, I can set them equal. So 6x minus 2 equals 5x plus 7. We're going to go in and circle our x's, box in our numbers, and now I want you to solve the rest of the problem. So I've set it all up for you. You are solving for x, and then once you found x, then you need to go back in and plug it into EC, because that's what you were trying to solve for. So you would have to go plug it back in, whatever you get down here. So whatever this number is, plug it back in to 3x minus 1, and then you'll get an answer. See you tomorrow.